Question for you. Do you recall from our last learning activity what cataclysmic extinction event occurred beginning around about 2.5 billion years ago and really culminating about 2.3 billion years ago? And so this event is going to proceed and then ultimately allow for the increased cell size of the eukaryotic cell. I'm sure you're screaming at your monitors right now, the great oxygenation event or catastrophe, depending upon whether you're aerobic or anaerobic. Hopefully you watched that short video, the time that oxygen almost killed everything. But in short, 2.1 billion years ago, the Huronian glaciation has ended. The planet is warming. Oxygen has filled the atmosphere, and a protective layer of ozone, of O3, has formed in the upper atmosphere. Earth is now becoming more hospitable to life, at least as we know it. All that O2 in the atmosphere is now going to allow for cells to get physically larger. So now they can get by, the eukaryotic cell can get by with a smaller surface area to volume ratio, at least in part because of the increased partial pressure of O2. And it's not a coincidence that by 2.1 billion years ago, the atmosphere is filled with oxygen, and many of the anaerobic microbes have died off in this great extinction event, and we find the earliest fossil evidence of eukaryotic cells in rock that dates at 1.8 billion years ago. Recall that prokaryotic cells, they're only about 1 to 5 microns in diameter. These fossils are relative behemoths at 40 microns. They're 8 to 40 times larger than those tiny bacterial or archaea cells. What technique do we use to estimate the age of these rocks within which we find these fossils? Radiometric dating. You remember that.